So physical requirements and the temperature that a microorganism can use. Well, we saw at the very beginning that there were those hot springs and there were those icebergs and there was microorganisms growing on both. Not the same microorganism. Every single microorganism is going to have a growth rate or an optimum growth curve. There's going to be a growth curve where there's going to be a certain temperature or temperature range that growth occurs the best. And then there's going to be a range of temperatures where growth can occur. And then below that, growth will not be able to occur. So if it's too cold, a microorganism won't be able to grow. If it's too warm and too hot, a microorganism won't be able to grow. The difference is as every microorganism has its own growth curve. So it has its own temperature. Now we can classify these microorganisms in categories based on these temperatures, the minimum temperature that growth can occur to maximum and the optimum temperature. So we're going to talk about the different categories of that and how temperature affects it. Okay, so optimum growth temperature, this is where they grow the best. And if you'll notice, look at the curves on both sides of this. As we grow colder from the optimum growth temperature, we still get growth. They're still able to grow at a little bit cooler temperatures, but they're just not growing as quickly. So you don't get as much growth. And then the colder you grow, the less and less it happens. Why do we get the slow slope on this one? But as we raise the temperature, we reach our maximum growth temperature very quickly. I'm going to take a minute and let you think about that one. Okay, so as we go colder, metabolism is still ongoing, but metabolism, the molecules that are happening, the enzymes and everything going on, everything is moving more slowly, which means our growth continues. It just continues at a slower rate. When we put our foods in the refrigerator and we put it at a low temperature, we don't stop bacteria from growing. Anybody who's lost a piece of, leftovers in the refrigerator for a few weeks and comes back and finds them, microorganisms will still grow. Growth is still occurring, but in the refrigerator, it's growing more slowly. So you can eat leftovers the next day and then, the next couple of days. And if you left it out at the counter, your leftovers would very quickly grow bacteria and then you couldn't eat it because there would be too many bacteria there. So the slow side, when we decrease the temperature, works by slowing down metabolism. So growth is still occurring, but it grows more slowly. This is also why, have you ever heard the phrase, you've heard of those stories where you get the small child that falls into a frozen lake in the wintertime and they're underwater for like half an hour before they can get them out. And then they come back and they survive and they do okay. And we've heard those stories and that's great. And there's a phrase that they'll use in medical care where they say they're not dead until they're warm and dead. And that means that when they fall into the lake, normally you fall into a lake and you're underwater for 30 minutes, you're a goner, right? How long can you hold your breath? A couple minutes, maybe if you're a great swimmer, maybe a little longer than that. But after that, you lose oxygen. Oxygen can't get in. You deprive your brain of oxygen. And we know oxygen is a growth requirement. You have to have it. It's that final electron acceptor. We need it. We deprive our body, then you're dead, right? So how do these kids survive in a frozen lake for 30 minutes without oxygen? Well, it goes back to that growth curve and metabolism slows down, which means their need for oxygen slows down. Do they have enough oxygen already in their body circulating that they can keep alive at that very slow rate of metabolism? And that's what they're going for. So they pull them out of the frozen lake and, hypothermic, their body temperature has dropped. They may not be able to find a pulse. You're not dead until you're warm and dead. They will continue life-saving measures. They'll get them to the hospital. They will slowly raise their body temperature and then see what happens. And many times they're okay. So that is because of what happens on the colder side of that growth curve. Metabolism slows down. All right, what's happening on the warmer side? What happens to proteins when you raise the temperature? We talked about denaturation. Proteins will denature, fall apart. I think we've already talked about if you crack an egg for breakfast and you put it in your frying pan, the egg white, that's that protein, that albumin protein, it's there, and you put heat onto it, it's going to change, right? It's going to cook, and then that is a permanent condition. It will stay denatured. So on the upside of that, as we heat up things up, we get a very quick fall off, because once proteins denature and fall apart, they lose that 3D conformation and they can't bind to enzymes, and you're dead, right? Okay, so that is our growth requirements, our temperature, and how that works. You can see these are replica plating. There's a technique where you can plate bacteria in the exact same place on 3 plates, and you can see at 37 degrees Celsius. That is an optimum growth temperature for a lot of bacteria. That is human bodies temperature. 37 degrees is 98.6 Fahrenheit. 37 degrees is our temperature of our human body. It's also the temperature we keep our incubators at when we talk about growing bacteria in lab. A lot of bacteria and all bacteria that affect humans, that are pathogenic bacteria, are in this category, and their optimum growth temperature is 37 degrees. You can see as they went to 30 and 22 that their growth fell off, and you can see that in the size of the colony. All right, so let's learn some words. Get your flashcards out. We're going to learn some words from that. And again, optimum growth temperatures are different for different types of organisms. They may overlap some. So let's learn some categories here. If a bacteria is a psychrophile. Now, I give you some grace in spelling, but do note this R here, this prefix psychro, means cold-loving, philic phials, cold-loving. This is not psycho, crazy bacteria, so do note this R as you're doing this. Psychrophiles are what we call the cold-loving bacteria. You should know the range. It's about -5 degrees Celsius, so below freezing, to about 15 degrees Celsius, and there are bacteria that that exist there. Those are the ones that are on those icebergs. Now, most of those don't bother us. They can sometimes sometimes infect things in the refrigerator, like cold food spoilage. If there's foods in a refrigerator and they are contaminated with psychrophiles, they can spoil it. But they don't survive these 15 degrees Celsius. They do not survive in humans. They do not cause us a disease for that. Most of the ones that cause as a disease, almost all of them, I would say all of them, are mesophiles. Meso, so think moderate temperatures, mesophiles. And this ranges 20 degrees Celsius to 40 degrees Celsius. For your frame of reference, we've already defined body temperature is 37 degrees Celsius. Room temperature is about 23, 24, 25 degrees Celsius, 24, 25 degrees Celsius. So you can see room temperature and body temperature is where these organisms thrive well and grow well. So a range of 20 to 40. So all of our pathogens, the ones that affect us in our body, fall into this group. All right, those are mesophiles. And know the ranges. Thermophiles, these are our hot-loving bacteria. They grow at temperatures above 45 degrees. So these are our hot springs, bacteria that were in that Yellowstone hot springs. Also composting. Does anybody ever compost? If you reach your hands into that compost, it's warm. There are bacteria that are responsible for that degradation of the food scraps and whatever you put in your compost piles. These are thermophilic bacteria. And in fact, if your compost isn't doing very well, one of the things they'll tell you to do is go to a compost pile that is doing well and take some of the soil. You're taking the soil with those bacteria and inoculating your compost pile, putting those bacteria in there, and then their metabolic pathways will end up actually raising the temperature in that, and they will survive well and get your compost pile going. There is a category called hyperthermophiles, and these grow above 80 degrees Celsius, which is really hot. When you think boiling is 100 degrees Celsius. They are adapted for these very hot environments, deep sea, volcanic ocean vents. Their proteins have extra bonding to keep them together when most proteins would be denaturing when we get to these higher temperatures. So there are some microorganisms that we found that we have classified in this hyperthermophile categories. Okay.